Hello students, so let's try to solve one more problem from JEST 2022, and it's a very nice problem, and this is from spin as well as there is a lot of concept of mathematical physics, matrices, and all these things. So let's straightforward go to question. So there is one operator is there, that is M operator. This is nothing but 2i plus sigma x, sigma y, sigma z, and this is Pauli spin matrices for spin half particle. So all these are 2 cross 2 matrices, and we have two vector, and these are obviously column vector. So you can say these are two state. One is u state 1 0, another is v state 1 minus 1. So what we have to do, we have to find the basically the matrix element of operator root under m u v. So this is u and this one is v, and we have to calculate what is root under m. So obviously, the first task is that we have to write these all thing in a matrix form. So when we all know that sigma x, sigma y, sigma z is so identity matrix, we all know that 1 0 0 1. Sigma x, we all know that this is 0 1 1 0. They all are Pauli spin matrices. Sigma y, we know that 0 minus I 0. And sigma z is famous 1 0 0 minus 1. And when we will put it here, so I have calculated these all things. So we have 2 cross 2 matrix, and this matrix is basically we have 3 2 0 1. This is wonderful matrix. And if we calculate the eigenvalue, and we have to calculate eigenvalue with m minus lambda I, and then we have eigenvalue as 1 and 3. Sorry, is equal to 0. Then lambda is equal to 1 and 3. And for lambda is equal to 1, we have eigenvector. So I have already calculated. So lambda is equal to 1. We have eigenvector that is 1 minus 1. So this 1 minus 1 is exactly this v ket. So we can write it in a ket form. So this is just a v ket. And for lambda is equal to 3, we have eigenvector 1 0, that is exactly 0 ket. So this is a very nice information that these column vector are nothing but the eigenvector of this particular matrix M, and this eigenvalue is non-degenerate, so it can be easily diagonalizable. So if we will diagonalize this particular matrix M with some matrix P, and that P can be formed with on a basis of this eigenvector of this particular matrix. So I can create this P matrix, and this P matrix is equal to 1 0 and 1 and minus 1. We can find the P inverse, and luckily this P inverse is also same one. So this is 1 0 1 minus 1. So you can also see that this can be this is basically unitary matrix. So if we have this particular P and P inverse, then we can find the P inverse M P. It's some diagonalizable matrix, and this M and D is basically similar matrix, we can say. So when we will calculate this one, then obviously this value is nothing but the eigenvalue, and this is eigenvalue for lambda is equal to 3. So we have 3 0 0 1, and which is diagonalized in nature. So if we are going to calculate this one, you can easily calculate from this matrix multiplication. So this is the thing. Now, if this is going to happen, then we can write P inverse any function of M. P is also written in a diagonal form. So if we are going to use this thing, so that value, so this value is equal to P inverse root under M. P can be written as root under 3 0 root under 1. So this is my equivalent matrix. Okay, so this is my equivalent matrix. We can write this thing. So my root M matrix I can write in this form also. So if we are going to write this form, then we have to calculate the matrix element. So I can use this space. So we have to calculate the matrix element U root M V. So U will be my 1 0, that is in a column vector. Root M we can write root 3 0 0 1, and you can write root 1 also, and V matrix is 1 minus 1. And when you will calculate this particular thing, so this can be easily calculated, and this value is equal to root 3, and that is 1.732. So this is wonderful problem. It's a classic problem. You can see the first thing we have to learn that how we can write any matrix in a functional form. So this is just written in a form. See, P inverse Fm P can be written as F lambda 1 0 0. So 0 F lambda 2. This type of thing you can easily write. So you can write F lambda in a diagonal form. So something like this. So we can write this particular thing. And if we know this particular thing, then we can usually use this particular similar matrix, and we can find this particular matrix element. So this is wonderful problem. You should try with yourself. If you have any suggestion, you can just give us that suggestion on our YouTube or in our Telegram or from the WhatsApp. You can just send which of any appreciation or any suggestion. You can just tell us. Thank you.